I mean, I jumped from rice to cotton, so I think I can do some more gymnastics.
You said a few times, like, you would work with breeders who wanted to work with you, but what kind of data would you be looking for to work with their breeder?
I guess breeders who are already trying to incorporate high throughput phenotyping in their program or as part of their research would be very valuable, because what we're trying to do is to be able to parameterize these types of models, we need to get kind of like the temporal resolution over time to be able to try to validate these models. So, but I think that it seems like the breeders here are doing that and going down that direction. So I think there would be some easy hooks that we could find. And I guess a lot of it is also what people are willing to phenotype that's more conventional, because we do need to ground truth a lot of this stuff. So for instance, like the leaf area index is a very important variable in the model that we can use for validation. And some of the imagery, it needs to be ground truth because a lot of times they will underestimate LAI. So there's going to be a little bit of like an iterative nature for the collaboration, and maybe we can find graduate students who are willing to go out and help us with the ground truthing measurements and some of the more intensive physiological measurements that we would need to validate, like leaf water potential. But it's fun. Doing physiological measurements is really fun. I spent a month out doing pre-dawns and middays and getting up at 1 in the morning to measure these.
Bobby.
I have another question.
Oh, you can.
Oh, I just wanted you to go back like 2 slides to your idea of developing like G/E models for cassava.
Yeah.
So could you talk a little bit about the rationale for why you would do that?
So my rationale to going after cassava is purely from well, first of all, it's a really interesting crop to me because of the below ground and sort of resource allocation, but also in a more opportunistic perspective, there's a lot of money and there are loads of genomic resources. So they're already doing genomic prediction. That's been kind of the target of all the millions from the Gates Foundation. And so to extend that out to more heterogeneous environments and stress environments, I think we need to be able to layer on some biological information about the processes that go on underneath. So it just seemed like a natural extension.
And then why G/E models?
Oh, because this is what my research is on, trying to use process-based models, parameterize them at genotype level, and then having them play out over many, many different environments. It's just from personal interest, I guess.
I guess I'm just looking for like what, what that would achieve in cassava, I guess, right?
So if breeders are trying to use genomic prediction to make selection, then having G/E models that allow you to make these predictions over many different environments may give you some more information to do that selection. So I think more information for decision making would be beneficial.
Thank you for the presentation. What if all the breeders want to work with you?
Yeah.
How you will prioritize?
And it's based on a popularity.
Or who went first?
That's a really good question.
You don't have to answer it.
That's a really good question.
Yeah. But I think that's going to be maybe a possible scenario.
Any other questions?
I want to go last.
Just one motion.
Just one. So we all have a question over Miguel and then myself.
Miguel.
You mentioned water potential was as one of the maybe potential variables to measure. Do you think it is feasible in the breeding context when you have to make measurements pre-down of 300 lines?
So that's where these awesome engineers come in. So they are creating, and this technology may be kind of far down the line. I mean, for now we may have to start doing just these point measurements the conventional way. So for leaf water potential, there's a lot of technology that's coming out that's allowing more real-time data to be coming up and getting logged more or less continuously. I mean, you kind of have to go out there and kind of fix it every 2 weeks or pick a different leaf because they stop working. But that's something those are the technology I'd be really interested in investing in. Trying to get not just imagery data, but using this sort of real-time sensing data for measurements that really connect directly to the physiological trait. So even in, like, there's a chemical engineer who's got a patent out to measure, and actually Duke's on the patent, it's called aquadescence, using nanotechnology and fluorescence to sense water status, so as a proxy for leak water potential. It's not quite there yet, they still have to inject it into the plant, so it's not high throughput by any means right now, but these are sorts of the technology that's coming on board, so we have to watch out for what's coming out and how we can leverage those innovations.
Okay, Mosa.
Yes. So our department has about 3, 4, 5 plant leaders,
Yeah.
but my question is not about those. I want to give you the opportunity to tell us how you work with cropping system scientists, and specifically the intercropping future thing with collaborating with computer science. So this is your chance to communicate with those group of people too.
I guess I want to know first what the constraints are, because this is a very new field for me. This is a new area of research, and I'm not the type of person to go out guns blazing with a prescription at all. I really want to get a chance to understand what cropping systems people work on right now and what their interests are, because I want it to be tied back into like reality.
So for example, if we have a soybean and
Yeah.
wheat double cropping or relay cropping, which we have Sean Castile here, see what you can do for him.
Sure.
Yes, what can you do?
As far as I know, it's really interesting because right now we just model like the single crop, right? Parameterizing for that crop, that's it. I don't know off the top of my head any widely used crop model that incorporates this interaction. And so we'd have to make a new model. Like we'd have to make a new modeling framework that allows the species interaction. And I think it can be done as long as we define what that interface is. It would take data collection, of course, and trying to study the interactions. But I mean, and then once we get those, then we can explore the state space, and we can let loose the computer scientists who will optimize the
Okay. Hold it. Corbett's going to ask you a question after we get done thanking you.
No, my question was to ask Mosin, what can you do for her? What can you do for her?
I'll tell her.
So we have just a 15-minute break where she's going to get sort of a little break, a little rest, and then we're going to reconvene in here at 11 for the fact that we're interested in the research.
Yeah, you should have one
Really?
Good. Good. Yourself?